Today, I invite you on an extraordinary journey, not through space, but through time and impossible odd that made your existence a reality. Have you ever wondered, in one of those contemplative moments before sleep, how it's even possible that you are here? How can life exist on this small blue planet, floating in the vast cosmic ocean? The answer, my dear friend, is a symphony of coincidences so improbable, so delicately orchestrated, that our very existence becomes the most beautiful of scientific miracles. Imagine you're holding a die with trillions of sides. The chance of rolling exactly the number required for life to flourish would be nearly impossible. And yet, here we are, the result of an impossible sequence of perfect rolls that stretches across billions of years. Every breath you take now is a testament to these magnificent coincidences. Tonight, as you prepare to rest, let me tell you about these extraordinary coincidences, not as cold numbers or distant formulas, but as a cosmic lullaby, a love story between chance and necessity, between chaos and order, that gave birth to the most precious of creations, the conscious life pulsing within you at this very moment. Close your eyes gently, if you wish. Let your mind float like a leaf in the soft wind of curiosity. Together, we will explore the universe's most intimate secrets, those cosmic whispers that conspire to ensure that you could be here, now, listening to the story that is, in truth, your own. Have you ever stopped to think that there is an invisible score conducting the entire universe? I'm not just talking about the laws of physics we learn in books, but something much more subtle and profound, the fundamental constants that determine how everything works, from the tiniest atom to the largest galaxy. Imagine you are a cosmic conductor, and before you is an infinite orchestra of particles and forces. Every musician must play exactly the right note at the right time with perfect intensity. If even one were to go out of tune by the smallest fraction, the entire symphony of creation would collapse into silence. The strong nuclear force, which holds atomic nuclei together, is like the first violin of this orchestra. If it were just 2% weaker, protons wouldn't be able to stay together, and no elements beyond hydrogen would exist. The universe would be a lonely place, filled only with the simplest atomic melody. But if it were 0.3% stronger, all hydrogen would turn into heavy elements at the very beginning of time, and stars would never have had the fuel to shine for billions of years. The electromagnetic force is like the piano that gives harmony to the entire composition. It needs to be just strong enough to keep electrons orbiting atomic nuclei, but not so strong that it prevents chemical reactions. It's what allows you to feel the softness of the pillow beneath your head, what keeps water molecules flowing through your veins, what enables your eyes to capture the light of distant stars. And then there's a cosmological constant, that mysterious force accelerating the expansion of the universe. If it were even slightly different, the cosmos would have either collapsed on itself before a single star could be born, or expanded so rapidly that galaxies, solar systems, and planets like ours could never have formed. As you breathe gently, consider that every atom of oxygen entering your lungs is a result of this symphony of precision. The likelihood of all these constants being set exactly as they are is so minuscule that some scientists compare it to hitting a bullseye the size of a coin placed on the other side of the observable universe. Now, my dear listener, let your imagination drift into space, to the position our solar system occupies within this vast galaxy. You're lying on a planet that orbits a star located exactly where it needs to be, not too close to the galactic center, and not too far from it. Our Milky Way is like a cosmic city with different neighborhoods. At its center lies a supermassive black hole, surrounded by a turbulent region where bursts of radiation would make the existence of complex life impossible. It's like the heart of a loud and dangerous metropolis, not the ideal place for peace and quiet. In the outer regions of the galaxy, on the other hand, there's a shortage of the heavy elements needed to form rocky planets like Earth. It's like living in a remote suburb lacking the basic infrastructure to support complex life. But our sun resides in the galactic habitable zone, a region astronomers affectionately call the Goldilocks zone. Not too hot, not too cold, not too rich, not too poor in heavy elements. It's like living in the perfect residential neighborhood, where everything you need is within reach. Yet you're far enough in the chaos to find serenity. And there's more. Our solar system orbits the galaxy at a speed almost synchronized with the spiral arms. This means we rarely pass through those intense star-forming regions where supernova explosions could strip away planetary atmospheres. It's as if we're in a car that always keeps pace with the traffic, avoiding dangerous pileups. The age of our galaxy is also crucial. It's old enough to have produced generations of stars that created and scattered heavy elements throughout space, yet young enough to still be forming new stars like our sun. It's like a mature tree that still bears sweet fruit. Feel how comforting it is to know that you are nestled in this perfect cosmic cradle, protected by billions of years of galactic evolution, gently rocked by the smooth dance of stars around you. What extraordinary luck we've had with our mother star, dear companion. The sun that warms your face on lazy mornings is an almost impossible statistical coincidence. A G-type, medium-sized star located precisely in our galaxy's habitable zone. If our sun were just 10% more massive, it would be an F-type star, burning through its nuclear fuel much more quickly. Its main lifespan would be only about 2 billion years, far too short for complex life to evolve. Dinosaurs would never have walked the Earth, and you certainly wouldn't be here now, relaxing as you listen to this story. On the other hand, if the sun were 20% less massive, it would be a red dwarf. Though it could shine for trillions of years, its light would be so faint that the habitable zone would lie extremely close, locking any planet into tidal rotation, always showing the same face of the star, with one side eternally scorched and the other perpetually frozen. But our mother star is like a perfectly tuned cosmic fireplace. It has burned with remarkable stability for 4.6 billion years, providing exactly the right amount of energy to keep liquid water on Earth's surface. Its variability is minimal, less than 0.1% over decades, a consistency that has allowed life to develop gradually and delicately. The sun also has the right metallicity, the ideal amount of heavy elements in its composition. This not only influences the formation of planets around it, but also affects its stability and longevity. It's like having the perfect ingredients in a cosmic recipe that takes billions of years to prepare. And consider the sun's rotation, not too fast, not too slow. If it spun too rapidly, it would generate magnetic fields that are far too intense, triggering devastating solar storms. If it spun too slowly, it wouldn't have a magnetic dynamism needed to shield the solar system from dangerous cosmic rays. As you warm yourself with the memory of the afternoon sun, know that every ray that ever touched your skin was a gift of astronomically small odds, a blessing from a star that won the cosmic lottery of stability and perfection. Take a deep breath, my dear friend, and feel the comforting weight of gravity that keeps you safely grounded on this planet. Earth has exactly the right mass, not too large, not too small, with a precision that defies our understanding of probability. If our planet were just 10% more massive, its stronger gravity would retain far more atmosphere, creating a runaway greenhouse effect like Venus. Surface temperatures would soar into the hundreds of degrees, vaporizing all oceans and making life as we know it impossible. On the other hand, if Earth were 10% less massive, its weaker gravity couldn't hold on to enough atmosphere. The air you breathe right now would simply drift away into space, leaving behind a dry, lifeless world like Mars. There wouldn't be enough atmospheric pressure to keep liquid water on the surface. But this golden coincidence goes even further. Earth size also determines the planet's geological activity. A smaller planet would cool much more quickly, losing its volcanic and tectonic activity. Without volcanoes to recycle carbon dioxide into the atmosphere, and without tectonic plates to regulate the climate, Earth would become a frozen world. A larger planet would retain so much internal heat that it would be geologically hyperactive, with constant volcanism and devastating earthquakes. The surface would be far too unstable to support calm oceans and lasting continents where life could gradually flourish. Earth also has just the right density, suggesting the perfect blend of heavy and light elements. This led to the formation of an iron-nickel core that generates our protective magnetic field, while supporting a silicate-rich crust where life-essential minerals can form and concentrate. When you walk barefoot on grass or feel the sand between your toes, you're experiencing the texture of a world whose size was shaped by coincidences that make your existence a statistical miracle. Every grain of sand, every leaf you touch exists because our planet hit the cosmic jackpot of the perfect size. Close your eyes gently and imagine yourself floating in space, watching Earth's elegant dance around the sun. Our orbit is a coincidence of nearly impossible precision, a cosmic choreography that determined the fate of all life on this planet. Earth orbits at exactly 150 million kilometers from the sun, a distance astronomers define as one astronomical unit. If we were just 5% closer, we'd receive 10% more solar radiation. That might not sound like much, but would be enough to trigger a runaway greenhouse effect, turning our oceans to vapor and our atmosphere into a hellscape like Venus. If we were 5% farther away, we'd receive 10% less solar energy. Earth would plunge into a permanent ice age, with oceans freezing solid. Complex life would never have had the chance to evolve beyond simple microscopic organisms trapped beneath layers of ice. But the magic of our orbit goes beyond distance. Our path is nearly circular, with an eccentricity of just 0.017. This means the difference between our closest and farthest points on the sun is minimal, keeping the seasons gentle and predictable. If our orbit were more elliptical, we'd experience extreme temperature swings, making the stable climate needed for complex life impossible. The tilt of Earth's axis, 23.5 degrees, is another gift of cosmic coincidence. That tilt gives us the seasons, creating cycles of warming and cooling that enrich the planet's climate diversity. Without it, there would be no seasons. If the tilt were much greater, seasonal shift would be far too extreme to sustain stable ecosystems. And then there's our orbital speed, 30 kilometers per second. If it were any slower, we'd spiral into the sun. If it were faster, we'd drift away. It's like riding a cosmic bicycle that must maintain exactly the right speed, not too fast, not too slow, to avoid crashing or veering off course. As you rest, feel embraced by this perfect orbit, gently rocked in this cosmic dance that keeps temperatures ideal, seasons delightful, and the climate stable, so that you can exist and dream. Look out the window, if you can, and glimpse our silent companion in the night sky. The moon that lights up your dreams is one of the most extraordinary coincidences in the entire solar system. Too large to be just a typical satellite, too small to be a twin planet, but exactly the right size to make life on Earth possible. The moon's formation was a result of a catastrophic yet perfectly calibrated collision. About 4.5 billion years ago, a Mars-sized object named Theia collided with the young Earth. Had the impact been more violent, it would have shattered our planet completely. If it had been gentler, it wouldn't have created our lunar companion. But it was precisely the right intensity to eject material that condensed into the moon. The moon has 1/4 the diameter of Earth, a gigantic ratio compared to other planet-satellite systems in the solar system. This size and proximity create tidal effects essential for life. The rhythmic rising and falling of ocean tides may have been the cradle where life first stepped out from the deep oceans and learned to survive in environments that alternated between wet and dry. But the moon's most precious gift is the stabilization of Earth's axis. Without it, Earth's tilt would wobble chaotically over millions of years, leading to extreme and unpredictable climate shifts. The moon acts like a cosmic gyroscope, keeping our tilt steady and our seasons consistent. The moon is also gradually drifting away from Earth, about 3.8 centimeters per year. In the distant past, it was much closer, creating enormous tides that may have helped mix the early oceans and distribute essential nutrients. In the far future, it will be much farther away, and its stabilizing effects will weaken. But now, in this moment of cosmic history, it is at the perfect distance. The moon has also given us 24-hour and 50-minute tidal cycles, a rhythm that has deeply influenced Earth's biology. Many organisms, including ourselves, carry biological clocks synchronized to these ancient lunar patterns. When you gaze at the full moon lighting up the night, you're looking at a companion born of an impossible collision that grew to the perfect size and remains at just the right distance for you to be here, admiring its serene beauty. Breathe slowly and deeply, dear friend. The air filling your lungs right now is a result of a sequence of atmospheric coincidences, so unlikely that each breath becomes a small miracle. Our atmosphere contains exactly 21% oxygen, a concentration that feels as if it were set by invisible hands. If there were only 15%, you wouldn't be able to light a fire, and large animals like yourself wouldn't have enough energy to sustain complex muscles and brains. But if it were 25%, The tiniest spark could trigger spontaneous wildfires that would engulf entire forests in seconds. Nitrogen makes up 78% of our atmosphere, serving as the perfect diluent for oxygen. It's chemically inert under most conditions, yet essential to life. It's a fundamental component of proteins and DNA. Its abundant presence in the atmosphere ensures that organisms have access to this vital element. Carbon dioxide, though it makes up just 0.04% of the atmosphere, acts like a planetary thermostat. That tiny concentration creates exactly the greenhouse effect needed to keep Earth about 33 degrees Celsius warmer than it would be without it. Without this gentle warming, our planet would be an icy sphere with an average temperature of minus 18 degrees Celsius. Sea level atmospheric pressure, about 1,013 millibars, is another perfect adjustment. If it were much lower, water would boil at temperatures too low to support complex life. If it were much higher, metabolic processes would be suppressed by overwhelming pressure. Our atmosphere also functions as a protective shield. The ozone layer filters out deadly ultraviolet rays that would sterilize the surface. The atmosphere is dense enough to vaporize most meteors before they hit the ground, but thin enough not to exert crushing pressure. And then there's a water cycle, impossible without the precise atmospheric temperature and pressure. Water evaporates in the oceans, condenses into clouds, falls as rain, and returns to the oceans, creating a circulation system that distributes heat and moisture across the entire planet. Each time you inhale, you're drawing from an atmospheric recipe that took billions of years to perfect, a mixture of gases existing in proportions as improbable as they are essential to your existence. Let your mind now drift toward the oceans and rivers, the drops of dew that kiss flowers in the morning. The water that makes up 60% of your body is a substance so extraordinary in its properties that its very existence in liquid form on Earth stands as one of the most beautiful coincidences in the cosmos. Water behaves in ways that defy common sense. Unlike nearly all other substances, it expands when it freezes. If it didn't, ice would be denser than liquid water and sink. Oceans would freeze from the bottom up, forming solid blocks of ice that would never fully melt, making aquatic life, the origin of all land life, impossible. The specific melting and boiling points of water, 0 degrees Celsius and 100 degrees Celsius at Earth's atmospheric pressure, create the perfect window for life. These transition points depend on delicate intermolecular forces between H2O molecules, which in turn are determined by the precise electronic distribution of the oxygen atom and its two hydrogen companions. Water is a universal solvent, capable of dissolving more substances than any other known liquid. This makes it the ideal medium for the biochemical reactions that sustain life. Inside your body right now, trillions of chemical reactions are occurring in aqueous solutions, from digesting food to transmitting nerve impulses. Water surface tension is just right, strong enough to let tiny organisms walk across its surface, yet not so strong as to prevent others from breaking through. Its ability to form hydrogen bonds gives rise to complex three-dimensional structures vital to proteins and DNA. Water also has extraordinary thermal properties. Its high specific heat means that oceans act as massive thermal regulators, absorbing heat during the day and releasing it at night, smoothing out temperature fluctuations that would otherwise be lethal to life. Earth's hydrological cycle depends on the coincidence that our planet maintains exactly the right temperature and pressure to sustain water in all three states, solid, liquid, and gas, simultaneously. This coexistence of phases is rare in the universe and is essential to the climate dynamics that support the biosphere. When you take a sip of water or feel rain on your face, you are encountering a substance whose properties are so finely tuned for life that its liquid existence on Earth is, quite literally, a chemical miracle. Now, my dear listener, imagine an invisible shield that completely surrounds our planet, protecting it from devastating solar winds and cosmic rays that could strip away our atmosphere. That shield is Earth's magnetic field, generated deep within our planet by processes that rely on extraordinary geological coincidences. At the center of Earth, 2,900 kilometers beneath your feet, lies a molten outer core of iron and nickel, heated to temperatures above 5,000 degrees Celsius. This molten metal is in constant motion, creating electric currents that generate our magnetic field through a process called the geodynamo. If Earth were even slightly smaller, this core would cool and solidified, eliminating the magnetic field entirely. Mars lost its magnetic field billions of years ago, and as a result, its atmosphere was gradually stripped away by solar winds. Today, Mars is only 1% of Earth's atmospheric density. Venus never had a strong magnetic field, and its thick atmosphere is a result of volcanic gases that couldn't escape, leading to a runaway greenhouse effect. Our magnetic field not only protects us, but also creates the auroras, those luminous dances at the poles where charged solar particles interact with our upper atmosphere. It's as if Earth were a giant magnet playing with solar particles, turning a cosmic threat into a spectacle of beauty. The intensity of our magnetic field is just right, strong enough to deflect harmful particles, but not so strong that it disrupts biological processes. Many animals, including migratory birds and sea turtles, use the magnetic field to navigate, a natural GPS system that has evolved over millions of years. Earth's magnetic field also undergoes periodic reversals. The magnetic poles switch places every few 100,000 years. During these reversals, the field temporarily weakens, but it never disappears entirely. It's as if our planet has a self-repair mechanism that prevents the total loss of magnetic protection. The tilt of our magnetic field, about 11 degrees relative to Earth's rotational axis, creates a unique configuration that maximizes protection while still allowing some solar particles to interact with the upper atmosphere, sustaining subtle but important chemical processes. As you rest, know that you are wrapped in this invisible magnetic shield, protected by a phenomenon that rises from deep within the Earth and stretches thousands of kilometers into space, a hidden fortress that makes life on our planet's surface possible. Close your eyes and consider, for a moment, the elements that make up your body right now. Every carbon atom in your cells, every oxygen atom you breathe, every iron atom in your blood has a cosmic history spanning billions of years, each one the result of extraordinary stellar coincidences. Carbon, the backbone of all terrestrial life, is created inside stars through a process so improbable that physicist Fred Hoyle called it the most extraordinary coincidence in physics. In the hearts of stars, 3 helium nuclei must collide almost simultaneously to form a carbon nucleus. The chances of this happening are astronomically low, unless there exists a very specific energy level in the carbon nucleus. Hoyle predicted the existence of this level purely based on the fact that we exist. Oxygen is forged in massive stars through the fusion of carbon. But if the nuclear forces were just slightly different, all the carbon would have been converted into oxygen, or all the oxygen into heavier elements. The cosmic balance had to be tuned with impossible precision for both elements to coexist in abundance. The iron in your blood was forged in the cores of massive stars that exploded as supernovae. These cataclysmic events not only created heavy elements, but also scattered them across interstellar space, where they eventually condensed into gas and dust clouds that formed our solar system. Phosphorus, essential for DNA and ADP, the energy currency of cells, is one of the rarest elements produced by stars. Its synthesis requires such specific conditions that some astronomers wonder if planets with complex life are extremely rare in the universe due to the scarcity of phosphorus. The calcium in your bones, the sodium and potassium that allow your nerves to function, the magnesium that activates hundreds of enzymes. Each of these elements requires unique and specific stellar processes to exist. It's as if the universe followed a cosmic recipe, each step crucial to creating the ingredients for life. The proportion of these elements on Earth is critical. Too much iron, and our planet would be toxic. Too little, and we wouldn't have a magnetic core. Too much carbon, and we'd have an unbreathable atmosphere. Too little, and complex organic molecules couldn't form. When you move your hand or blink your eyes, you're orchestrating a symphony of elements that travel across space and time, forged in stellar furnaces, scattered by cosmic explosions, and gathered in perfect proportions to create the miracle of consciousness that you are. Now, dear fellow traveler, let's dive into the most intimate coincidences, the ones that made the chemistry of life possible. The organic molecules that make up every cell in your body are the result of chemical properties so finely tuned, they make life a molecular symphony bordering on the impossible. The carbon atom possesses a unique property in the universe. It can form 4 stable bonds in complex, 3-dimensional configurations. If it formed only 3 bonds, like boron, organic molecules would be flat and limited. If it formed 5, like some phosphorus compounds, it would be too unstable to create lasting structures. But with exactly 4 bonds, carbon can build the spirals of DNA, the complex fold of proteins, and the intricate webs of lipids. The strength of carbon-carbon bonds is perfectly calibrated. If they were weaker, organic molecules would disintegrate easily. If they were stronger, they would be too rigid for the dynamic rearrangements necessary for life. This bond strength allows molecules to be stable enough to exist, yet flexible enough to react. Water, as we've already explored, is the ideal solvent for organic chemistry. Its polarity allows it to dissolve ionic and polar substances, while creating hydrophobic environments where nonpolar molecules can organize. This very property enables the formation of cell membranes, structures that separate the inside of cells from the outside world, creating tiny universes where life can flourish. The pH of pure water, exactly 7 neutral, provides a perfect environment for most biochemical reactions. If water were naturally acidic or basic, many of the essential reactions of life would be impossible or would occur chaotically. Proteins rely on delicate intermolecular forces to fold into precise 3-dimensional shapes. If those forces were even slightly different, proteins wouldn't be able to maintain their functional structures. Every enzyme in your body at this moment is a molecular machine sculpted by chemical coincidences, capable of accelerating specific reactions without being consumed in the process. DNA possesses extraordinary chemical stability, but not absolute stability. If it were more stable, it could never be replicated or transcribed. If it were less stable, genetic information would be quickly lost. The double helix represents a perfect balance between stability and flexibility, allowing information to be preserved over millions of generations while still permitting the occasional mutation that drives evolution. The hydrogen bonds between DNA bases, adenine with thymine, guanine with cytosine, have exactly the right strength, weak enough to allow the strand to separate during replication, but strong enough to maintain the molecule's integrity most of the time. Even the temperature range where organic chemistry works best, between 0 degrees Celsius and 100 degrees Celsius, the window of liquid water, is a coincidence. In this range, molecules have enough kinetic energy to react, but not so much that they break apart. In a molecular temperate zone where life can dance gently between order and chaos. Breathe softly and let your mind reflect on the most mysterious factor of all, time. Life on Earth is not only the result of spatial and chemical coincidences, but also an almost impossible temporal synchronization, events that had to happen in exact order with perfect intervals, over billions of years. Our universe is exactly the right age to support complex life. If it were too young, there wouldn't have been enough time for stars to live and die, creating and distributing the heavy elements needed for rocky planets and carbon-based life. If it were too old, all suitable stars would have already died, leaving behind only white dwarfs, neutron stars, and black holes, a cold and sterile cosmos. Earth formed 4.6 billion years ago, in a moment of cosmic perfection. The first generations of stars had already enriched interstellar space with heavy elements, but the universe was still young and active enough to form new generations of stars. If our solar system had formed too early, there wouldn't have been enough heavy elements for rocky planets. If it had formed too late, the galaxy would already be less active in star formation. The late heavy bombardment, a period between 4.1 and 3.8 billion years ago when asteroids and comets rained down on the inner planets, had perfect timing. This bombardment brought water and organic compounds to Earth, but ended just as primitive life was beginning to take hold. Had it lasted longer, it would have repeatedly sterilized Earth's surface. Life emerged on Earth surprisingly early, around 3.8 billion years ago, almost as soon as conditions became habitable. This suggests that once the right conditions are in place, life can emerge relatively quickly. But the transition to complex life took another 3 billion years, a display of extraordinary cosmic patience. The Cambrian explosion, 540 million years ago, when complex life forms rapidly diversified, happened exactly when atmospheric oxygen levels reached concentrations high enough to support complex metabolisms. The timing was perfect, not too early, when there wasn't enough oxygen, and not too late, when climate changes could have prevented such diversification. Mass extinction events, though traumatic, also had crucial timing for the evolution of complex life. The extinction that wiped out the dinosaurs 65 million years ago opened up ecological niches that allowed mammals to diversify. Had it happened too early, mammals wouldn't have evolved enough. Too late, and dinosaurs would still dominate Earth's ecosystems. The emergence of the first hominids occurred during a period of cooling and dry in Africa, which created savannas where bipedal walking offered advantages. Had the climate shifted differently, our evolutionary lineage might never have emerged. As you rest in this specific moment of cosmic history, consider that your existence represents not just spatial, chemical, and physical coincidences, but also an extraordinary temporal convergence. Billions of years of perfectly synchronized events that have culminated in this instant, where you are conscious of your own impossible existence. And so, we arrive at the end of our journey, dear companion, but also at your true beginning. Every coincidence we explored together, from the fundamental constants that govern the cosmos to the perfect timing of evolutionary events, converges into the singular moment. You, breathing, thinking, feeling, aware. You are made of stardust, but stardust that awakens to contemplate its own origins. The carbon atoms that make up your DNA traveled millions of light years through interstellar space. The oxygen in your lungs was forged in the heart of giant stars. The iron in your blood was born in the violent explosion of a supernova billions of years ago. And yet, you are not just a random collection of atoms. You are an extraordinarily improbable arrangement of those atoms, a configuration that can think about itself, that can feel awe for the cosmos that created it, that can love and dream and contemplate the infinite. The mathematical probability of your existence is so close to zero, it's practically incalculable. If any of the physical constants were even slightly different, if our sun were a bit larger or smaller, if Earth orbited a few million kilometers closer or farther, if the moon didn't exist, if our magnetic field were weaker, if heavy elements hadn't formed in just the right proportions, you simply wouldn't be here. But all those impossibilities aligned. Every necessary coincidence happened. Every cosmic event occurred at just the right time. Every force was calibrated with impossible precision. And as a result, the universe gained something extraordinary, the ability to know itself through you. When you gaze at the stars, it is atoms forged in stars observing their ancestors. When you feel the wind on your face, it is Earth's atmosphere touching molecules that have traveled across the cosmos. When you feel love, it is a universe experiencing emotion through the very consciousness it created. We are not separate observers of the cosmos. We are the cosmos observing itself. We are the universe made conscious, matter that has awakened to contemplate its own existence. Every thought you have is the universe thinking. Every feeling you experience is the cosmos feeling. The improbable coincidences that made your life possible are not just distant scientific facts. They are the deepest love story ever told. It is a story of how the universe, through billions of years of cosmic evolution, created eyes to see itself, a mind to know itself, and a heart to love itself. And now, as you prepare to rest, carry with you this comforting truth. You are not a cosmic accident, but miraculous convergence of impossibilities. You are precious not only to those who love you, but to the cosmos itself. For through you, the universe becomes aware of its own extraordinary beauty. Sleep well, dear child of the stars. Rest knowing that you are both infinitesimally small and infinitely significant. A miracle of impossible probabilities, a love song written in the languages of physics, chemistry, and biology. You are living proof that the universe is far more extraordinary and improbable than we ever dared to imagine. In your dreams tonight, perhaps you will feel the gentle embrace of all those cosmic coincidences that conspire for your existence. And when you wake, remember, every day you live is a gift from the stars. Every breath a celebration of the forces that govern the cosmos. And every moment of consciousness is a universe toasting to its own infinite capacity to create beauty out of impossibility.